It is my pleasure to introduce our second keynote speaker, Markus Leippold from the University of Zurich. So that's actually where I did my PhD. So I have a bit of a personal recollection. So first time I met Markus was in 2009. So I just moved to Zurich for my PhD, and he just actually moved back to Zurich after a 2-year stint at Imperial College in London. And back then, he was, at least to my mind, a sort of hardcore financial econometrician / engineering guy. So this is the kind of papers that he would publish back then. And I don't want to say this could never land him the job of keynote speaker at this conference, but I think I'm not going to lie that it's mostly his more recent research that actually landed him this job. And so Markus has pivoted towards doing a lot of natural language processing and applying it to corporate climate disclosures, which I think is kind of the intersection of the two perhaps most prescient themes of our time, AI and climate change. So he and his team have been incredibly productive. So I counted over 20 papers on NLP applied to climate finance, and that's just since 2022, so like the last 2.5 years or so. That's not all. So they also released several tools to the public, such as the IPCC chat, which is a chatbot that you can ask anything about climate change, and you can be confident that the answer you get is not going to be pulled from Joe Rogan's TikTok, but based on actual science. So I think these are all great contributions, and we're really happy to have you here. So ladies and gentlemen, please welcome Markus Leippold.
Well, thank you for having me here. Before I start, I just want to make one correction. So Michael was hallucinating. It's not IPCC chat, it's chatclimate.ai. And I'm going to tell you the story behind it during my keynote lecture. So
it works, actually.
Yeah, but these are some, people that did similar stuff a little bit later than us. It's another one, but it's not ours. So thank you very much for giving me the opportunity to give a keynote speech here. When Michael was contacting me, I first thought, well, keynote speech, finance conference, no. I'm probably not the right guy to do a keynote speech at the finance conference. The reason is that, well, as Michael was pointing out, in my previous life, I published a lot in financial mathematics. I did my PhD in, I shouldn't say, 1998, and then became professor after I spent a couple of years in industry in 2002. So I consider myself already as an old person. And at that time, I always thought that in order to impress people and the audience, I need to do a mathematical talk, as mathematical as possible. It changed a little bit, and today I'm even going to use PowerPoint slides. I mean, I've never dreamed of doing this in my entire career when I was younger. So today I want to talk about the facts and fantasies of generative AI. But I also have to admit something, which is, I'm Swiss, and in Switzerland, usually professors, they smooth out their academic career by becoming a board member at some Swiss private bank and stuff like that. So I could have done that, but I don't like to wear suits, business suits. So eventually there was another company that admitted me to their body of employees, which is Google DeepMind. They don't require suits, so I joined Google DeepMind. or first Google research back in 2018, 19. And whatever I say here has nothing to do with what I do at Google DeepMind. So whatever I say, it is not related to that company. But of course, it gives me a lot of insights of what is going on in the space of generative AI. And I don't know, when I was a school kid in high school, I came across a book. And the book was by Stanislaw Lem, a Polish writer and philosopher. And he wrote this book. He wrote other books like Solaris, for instance, is one of his most influential books. And he wrote a book which was called Thus Spoke Golem. And Golem in this novel was and that was actually written in end of the 70s, was published in 1981. And Golem was a highly intelligent computer for the military who developed some self-consciousness. And at that time, Golem 14 to be precise, decided to quit his job at the military and give lectures to the most known scientists of the time. So it was basically giving lectures about humanity, about consciousness, about intelligence, and the future trajectory of humanity to the leading scientists. That's quite astonishing, right? So back in 1980, there was some science fiction writer who already had this vision of what we would call today artificial general intelligence, this super intelligent tool that can teach you something about us, right? And today, I think we are not that far away anymore from AGI. I talk to scientists in computer science a lot, of course, because my heart is probably beating these days more for computer science than for finance, I have to admit. And they tell me that like a couple of months ago, we were talking about if AGI will happen. And today we talk about when will AGI happen. But this, of course, brings a lot of responsibility in the use of these tools. The generative AI today is probably for most of you kind of a fun tool. So use ChatGPT, you tell ChatGPT to write a sonnet in Shakespeare style, and it does a great job in doing so. One of my friends, his kids, they had some infight, which is usual, with the mother, and then they told the kids to write an excuse letter for the parents, and they did so, and it was outrageous. They were writing such a nice, heartbreaking letter, but of course they knew ChatGPT, so they were using ChatGPT to write the letter to the parents to excuse for what they have done wrong. So this is how you use generative AI these days. Or, for instance, if you want to wish somebody to the moon, like this person here, you can do that in a few lines. You send the Pope to the moon, and it looks great. And it's a lot of fun. But if you ask a question, for instance, like, this chair is broken, how can I repair it? Show me a picture. This is what you get from the most elaborated AI tool. Does that make sense? Not really, right? So probably we are still far away of using these fun tools for the real world. And that's why also the late Charlie Munger from Berkshire Hathaway was quoted from the meeting of Berkshire in 2023 that I think old-fashioned intelligence works pretty well. Maybe, I don't know, that's probably another extreme view, right? Because remember the old days, 25 years ago, exactly 25 years ago, a bit more, there were these two crazy students from Stanford that started to work out something in a garage and uploaded the first web page called Google. with the mission to organize the world's information and make it universally accessible and useful. But everybody is using Google these days, I hope still. Depends a little bit. But if you want to have really the information sources, you go on Google and you Google something, right? And at the time when Google was released, there were 25 million pages indexed. That's a lot, but today Google has indexed hundreds of billions of web pages. Imagine all this information overflow that we have, right? So we probably get drowned in the information that we can extract from Google. And when you Google something, you always have kind of a linear presentation of the most important pieces of information, whatever most important means. So probably the mission of Google should be to organize the relevant information and make it understandable, which is also something very important, and decision useful for, let's say, decision makers, policy makers, and others. So probably that should be the whole new mission for the tech companies like Google. And generative AI for this kind of purpose is actually an optimal tool, if it works, an optimal tool to get down to this relevant information and make it available, understandable, and decision useful. For that reason, I thought that I'm gonna go back in history a little bit and tell you about the so-called foundation models in natural language processing, which builds the basis for where we are today. And I want to start with the revolution that happened in natural language processing. And I was very happy and lucky that at the time that was happening in 2017. And you have to know that like 7 years in computer science is like 70 years in finance. Like that was kind of the Markowitz moment in computer science. When the transformers arrived, the transformers. So what are transformers? Transformers are neural network architectures that can actually, so this is a complicated picture, but I try to explain it in sentences. Transformers, so in the old days, you had sequence-to-sequence models. So basically you were looking at the text and you tried to input the last word, and then you have the new word and so on and so forth. So basically it was a very cumbersome method, usually based on so-called recurrent neural network, that after a while they have to be cut off and they lose the context. So with transformers, you were actually able to put all the text in a parallel fashion into the encoder and analyze the text and the words in its context. And by using this so-called self-attention mechanisms, so each word starts to learn which other words are important for its own meaning. And this is called self-attention, and is a paper that was published by Google researchers in 2017. It's called Attention is All You Need. And by now it's cited 120,000 times on Google Scholar. Oh, it has a big impact. I mean, I don't know of a finance paper that got 120,000 citations. I know of the most famous finance researchers that have, over the whole lifetime, 120,000 citations, but a single paper that got so many citations was kind of an amazing new breakthrough. But at that time, of course, natural language processing, unlike today, was more or less the domain of some Google nerds or other kind of nerds. So the first transformer model that then eventually was a great breakthrough and also got into other scientific domains was not the mighty transformer but the BERT model. And BERT stands for bidirectional encoder representation for transformers. BERT was basically one of the first models that really was able to understand words in its longer context. So for instance, if you have a sentence like, the chicken is ready to eat, and you do sentiment analysis on this sentence, it depends on the context, right? Maybe the chicken is telling a story about other chickens, and then the chicken is ready to eat. Maybe the chicken gets some corn or whatever. Or the mother is calling their children, saying that, hey, the chicken is ready to eat. So from the perspective of the chicken, the meaning and the context of this sentence has a dramatic impact. And models like BERT were actually able to, or are able to distinguish words in its context. And one of the first applications that I started to look into back in 2019 was actually, as I mentioned, at heart, I was a financial mathematician. So definitely the most exciting documents to read as a mathematician are regulatory reports. I will never read this, and I never read it, right? So I thought, hey, let's use BERT and do the job. That's great, right? So what we did is, because of my natural interest that was arising at the time in sustainable finance, because of my kids, actually, we started to analyze regulatory reports, and we thought that we want to analyze whether companies are talking about climate risk and different aspects of climate risk. There's physical climate risks, and there are transition climate risks. And they have, semantically, and they are hard to detect with pure keyword-based approaches. So we thought that we're going to use these contextual algorithms that can identify these kind of risks in a much sharper way. And then we annotated some data. We fine-tuned the original BERT model. And we thought, okay, now we have this measure. How do you measure the impact? And we thought that, okay, climate risks might be an extreme risk. So therefore, climate risk does not live on the risk premium because that's the expectation of the whole distribution, but maybe on the tails of the distribution. So why not look at credit default swaps? Because this is like a for out of the money put option. And maybe these risks are captured there. And we found actually that with the Paris Agreement coming in place, there was a big increase in the credit default swaps due to the transition risk indicator. And when this other guy became president, who probably will become president again, became president, then you saw a big decrease in the CDS spreads. And also you saw quite an interesting pattern in terms of the term structure. Paris Agreement led to more or less a parallel, highly significant parallel shift of the term structure, meaning that transition risk will be here to stay. Whereas for the Trump election, you saw that it's basically a shift in the steepness. And then we were luckily able to publish this research, although I had always, with all the papers, quite some discussions, no, not some discussions, some negative experience with referees and editors of the other journals, I would say, because they, this was, we had the paper ready end of 2019, beginning of 2020. So that was quite early at the time. And motivated nevertheless by this kind of success, we thought that we have to make BERT better for climate risk. And what you can do is, you cannot just fine-tune the BERT model, but you can also do the whole pre-training. So you give BERT a whole new set of text to learn the climate-relevant talking. And what we were then putting into the training corpus for BERT was, corporate sustainability reports, 150 or 500,000 articles that are related to climate. And then you do the pre-training, which is usually kind of masking words so that the algorithm has to predict the word, or taking out sentences so the model learns what the next sentence could actually be. So we created out of BERT, Climate BERT. And with Climate BERT, we were then able to analyze lots of different questions. So we wrote quite a lot of papers. So since 2020, actually, my team and I, we published or have written exactly 50 academic papers in the domain of climate science, sustainable finance, and natural language processing. So one paper that we did was we tried to analyze how corporations are communicating about climate change. Now, when we talk about finance, I mean, probably not you, because you are part of this conference where information plays such a big role, but we know that most of the information is actually not available as numbers. It's available as text. So therefore, if we have now tools that can analyze text, which is about 80% of all the information in the business domain, then we might get more insights into how the real world is actually working. So we wrote a paper on analyzing the cheap talk and cherry picking of corporate disclosures on climate risk along the TCFD guidelines, the Task Force for Climate-Related Financial Disclosures. And we found that companies tend to talk a lot about things where you can do a lot of boilerplate text, but they do not talk a lot about things that become measurable for academics. So stay away from that. The second paper that we were then writing was environmental claim detection, which is something very important especially for regulators. And these days we collaborate with European regulators because they use our algorithms to detect claims made by companies so that potentially they could analyze whether this is greenwashing and enforceable, something legally enforceable. So we generated this pre-trained Climate BERT and fine-tuned the pre-trained Climate BERT on environmental claim detection. That was more then published in a computer science conference, the ACL, which is the Association for Computational Linguistics, which is more or less the AFA for NLP. Then we wanted to analyze not just words, but also reality. Do words have an influence on reality? And what we did is the following. So we fine-tuned a BERT model that was able to analyze something which we then called the CTI. In finance, you always need these 3-letter acronyms to be successful, like ESG or whatever. So the CTI stands for the Cheap Talk Index. And the Cheap Talk Index was basically analyzing the company's commitments in the annual reports, because this is legally more important in the annual reports, identifying the commitments and the actions of companies, and then measure the specificity of these commitments, right? You can commit anything, but you need to be specific. What do you exactly commit? So we trained this model, and then the ratio of non-specific commitments over all commitments was the Cheap Talk Index. And then we started to think, what kind of hypothesis can we make? And one of the first interests that we had was we were analyzing the usefulness of these climate initiatives. Climate initiatives like the TCFD, like the Climate Action 100 or the Science-Based Target Initiative. Do they actually have an influence on how decision useful the information is that companies provide in their reports? Again, decision useful, because in the end, you read these reports and you make decisions. And the Cheap Talk Index was a great tool to measure actually the decision usefulness of this information. And we found that only the Climate Action 100 Plus initiative had an impact on the Cheap Talk Index. Why? Because what is the Climate Action 100 initiative? There, asset managers and investors commit to engage with the most polluting companies in their definition of their climate goals. So it's an engagement channel from an economic perspective. While a TCFD is basically a cheap signaling channel. So you can say as a company, hey, I'm TCFD, so I'm going to save the world, right? And that's it. The SBTI would be a signaling with external credibility assessment through the SBTI organization. We found that SBTI has actually no impact on the Cheap Talk Index, and the TCFD has a positive impact on the Cheap Talk Index. And we didn't stop there. We also wanted to understand whether Cheap Talk Index is used strategically by the companies. And we found that actually the cheap talkers, the biggest cheap talkers also have the highest increase in total emissions. Highly statistically significant. And what we also found is that looking at incidents in the media through rep risk data, we found that actually the cheap talkers are those with the most negative environmental incidents in the media. So actually, words, they do matter. You, one of my postdocs here, has given a presentation or a poster presentation about using this kind of tools for green patterns analysis. So I'm not going to repeat here. Then there are some low-hanging fruits that we just wrote up very quickly, but also got into top NLP conferences. So a tool that analyzes net zero commitments and a tool that also analyzes nature-related talks in corporate sustainability reports. All these tools are actually open source, so everybody can download these tools and use them. So also a lot of regulators are actually using our tools for their purposes. I mentioned that the last two publications were mainly low-hanging fruits, and the reason why these were low-hanging fruits is and was the arrival of the second generation of foundation models, which is ChatGPT. And this ChatGPT arrived in November 2022. Actually, I was writing at the time with the non-instruct based GPT-3, a small little article which I called Thus Spoke GPT-3. My interview with on climate change with a large language model, and I basically just published the interview with this large language tool at the time when ChatGPT was not yet here, and my argument was, hey, this reads like a professor giving some information to a journalist for some paper like Financial Times or whatever. It reads so perfectly nice and has enough depth that everybody can understand it, but still you cannot really use it for anything else than just killing your time with it. So ChatGPT arrived, and I recommend to everybody of you, because you're all public figures or will become public figures depending on your academic age, test ChatGPT with something you are absolutely sure you know. What do you know best? You best know yourself. So ask ChatGPT to write a biography about yourself. And I did that. So in November 2023, I wrote, I used GPT 3.5. So what did it respond? Or you cannot read, but it tells me that I was born in February 12, 1965. No. I look younger than I am, but it's 5 years away in one direction. Then it tells me that I attended the prestigious University of Zurich. University of Zurich is great, but right, Michael? But it might not be. Yes, I mean, prestigious, whatever. Okay, I feel flattered, of course. So yes, prestigious university where I pursued a bachelor degree in economics. And so, no, I was not studying at the University of Zurich. So wrong. And then academic journey continued with a PhD in economics at the University of Zurich. No, wrong. And then again, this last sentence, I did my research, foreshadowing of the groundbreaking work that would define his career. I mean, like 5 people read my paper in Annals of Statistics. So what should I say about this? Of course, yes. So I thought GPT-4 would do a better job. And yes, it did. Indeed, it did a much better job. So it tells me that I'm currently a professor in financial engineering at the University of Zurich. That's great. This is the best. My early life was marked by international experiences, having spent the first 3 months of his life. So when I was like this, in Alabama, and actually Birmingham, Alabama, followed by 3 years in Lyon, France, before settling down in St. Gallen. This is all true, actually. I was born in Birmingham, Alabama. My parents lived there for 6 years, and then we moved, after 3 months, we moved back. And I must have said that in some interview. So it picked up this stuff and uses this text as an indication of my broad international experience. 3 months old. You know, just, and the only thing that I noticed was, I didn't even notice anything, even not my diapers. So you see how these tools work. And then, as a last thing, I thought, let's do the greatest of all, the GPT-4o, and see what's going to happening. And it does actually quite a good job. So the usual blah, blah, like a trailblazer in financial risk management, blah, 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 blah. Then I asked, does he work for Google? And then he tells me that, no, of my knowledge, May 2023, I'm not working for Google. But now this is new, kind of new. I can search for the recent updates in the internet. And then I ask again, does he work for Google? And then he found actually, yes, I work for Google, DeepMind, but I still love University of Zurich and blah, blah, blah. I just work for 1 day per week for Google DeepMind. So that's fine, almost. So let's still here. It falls back into ChatGPT 3.5. Tells me that I did PhD in economics at the University of Zurich. So this is all wrong. So even GPT 4o is not yet up to the task of writing a biography about myself. And I invite you to, test it for your own. This is what I have shown relates to the problem of hallucination. Now, hallucination is like indeed a big problem. So it's like if you would walk through, I generated a picture. If you would walk through a field of miracle mushrooms and you would ask a nice looking android about your way to the airport, it gives you a nice little answer, but it's all hallucinated. So what you actually need to do, you cannot really ask a plain vanilla GPT model or large language model if you do not control in some way for the output, because it will hallucinate. And hallucination is actually not something bad. It's just how these models work, right? They are probabilistic machines. They just throw out words according to some probability distribution. and they make some very nice stories about the question you're answering. But also humans hallucinate, right? We as academics, we also have kind of a starting point of a story that we want to tell, and some end point that might not look that good, and then we start to hallucinate about how great this stuff is, and then we write a paper about it. I mean, maybe in pure mathematics, hallucination is a little bit more tricky. So how can we now tempt or make these models more trustworthy? And the way going forward is, there are different ways, but one really interesting way going forward is using so-called retrieval augmented systems, which is basically you force the large language model to retrieve information only from the text documents that you define. So you can define basically the knowledge that the large language model should extract from. And we started to work on that already more than a year ago. So I think in October 2023, there was a LangChain coming out, which is one of the first technologies that can be used to to build these RAG systems. I want to talk about different use cases that we constructed, and which hopefully will show you a little bit about the potential of these models for our real world. The first one was this chat IPCC, which we built in January 2023. We renamed it to Chat Climate. And the reason was that once we put out the Chat IPCC website, the Chat IPCC tool paper, I got an email from the IPCC communication office that I should rename this tool because they're not supporting this kind of AI tools because they're not controllable. And I said, yeah, okay, we rename it to Chat Climate, which was actually quite ex post a great marketing move, because now we collaborate with the United Nations and also the World Meteorological Organization on these tools. So we are heavily engaged with helping them to build systems that help them to make decisions. What is Chat Climate? Well, Chat Climate is a tool that tries to answer questions in the domain of climate change, whether it's a kid asking a question or a climate scientist or a student asking a question. And the answer should be grounded on the most important documents of humanity these days, which are the IPCC reports, which is kind of the lower bound of the state of the climate, because all the governments within the United Nations have to agree on the wording in the IPCC reports. I mean, it's really, if you think that climate change is a big problem, then the IPCC reports are the most important documents. Who read the IPCC reports? That's why I didn't read the IPCC reports, so I thought I'm going to make a tool. So if I have a question like, is it still possible to limit warming to 1.5 degrees? Then what this tool does, it takes this question, it searches in a vector database due to some measure. So in NLP, mostly everything is just vector algebra or matrix algebra. So it looks for the relevant documents or text passages and extracts these text chunks and then summarizes what it finds. And what is also important for the trustworthiness of the tool is that you force the model to tell you where it got this information from. So it should tell you, this is on page 1737 of the IPCC report working group 2 or whatever. So you get an answer, go on chatclimate.ai, try it for yourself. You get an answer. We didn't work on the UX anymore, so it might not look super nice, but at least you get an answer which is grounded in the IPCC report. And then you can also go back and verify whether this answer is actually somewhere detectable in the IPCC report. So that was one of our first tools that we released already some time ago. It got into a Nature portfolio publication, so Communications, Earth and Environment. But that was now already quite some time ago. And now we are currently working on ChatWMO. You can also try this tool. So this is something we developed for the World Meteorological Organization, which is part of the United Nations. And there you have a couple of documents. You can select the documents you wish for, and then you can you can pose a question and you get the answer back from the knowledge of the World Meteorological Organization. We didn't want to stop here. We wanted to go back a little bit into the finance domain, and the goal was actually to in 2008, I was writing a finance paper on credit ratings, and my argument was that, hey, you don't need credit rating agencies because, given the public information that you have, you can define a simple tool that incorporates accounting information and market information, aggregate that in a non-black box, and you get better predictions in time and through the cycle than any rating agency. So I published that, and I found that it has no impact on the industry at all. So I thought I'm going to try another round of disrupting the rating agency industry. And the goal was to disrupt it. I think we didn't manage to do so, but we created at least Chat Report. And Chat Report was the following problem. And it's also a paper, and all the code is actually open sourced, and you can also check it out on this website. So what was the motivation for Chat Report? Regulation, we all know, is overwhelming and becomes even more overwhelming in the future. And what a junior analyst at a rating agency usually does is the following. So you get the corporate sustainability report from Sony, for instance, 500 pages. You read it. At the same time, in computer language, it's in context. Your context window must be really large. So you have to put your 500 pages in your context. And then also for instance, the TCFD guidelines, regulatory guidelines on how corporations should ideally report on certain risks. And there might be other documents that tell you how you should do it. So you have to understand all these kind of documents, and then you have to assess a corporate sustainability report like the one from Sony, which 3 years ago was probably 500 pages. And we thought that we can speed this up quite quickly, because the TCFD is basically asking 11 questions. And the rest is kind of how you should assess the answer to these questions. So you have different questions like, how does the company's board oversee climate-related risks and opportunities? So as a junior analyst, you would have to start and, okay, Sony, on which page? I don't know. Okay, here it is. And then you write something up. The answer to this question is like this and that. But what you also want to do is an assessment of the answer. And we also incorporated an automatic evaluation of the answer based on the recommendations of the TCFD. So for instance, you have a question like, what target does the organization use to understand and quantify benchmark climate-related risks and opportunities? How is the organization performing against these targets? Then you have the answer for the JP Morgan report. JP Morgan Chase plans to disclose additional detail on its efforts. Then it comes with an analysis, and then it comes with a rating score from 0 to 100. So 0 is bad. So JP Morgan gets 20 for its, I think, 2020 report. I don't remember, but you have done that now through the AI tool. And you can expand that and analyze also the time series of it. So over the weekend, at some point, I analyzed about 11,000 corporate sustainability reports within 1 hour. I think how much time that would have taken a junior analyst. And of course, there was a lot of fine-tuning of the prompting system, some inclusion of expert knowledge on how to design these prompts, and so on and so forth. And as a sanity check, we also saw that the conformity was actually increasing over time when you look at these reports, which is nice, but this is just measuring the talk, right? So you have to be a little bit careful. But you know, rating agencies or even regulators could use this to analyze at scale this kind of textual information. What we also did, and I want to go quickly through these slides, is we extended the whole work in our newest paper, which was also sponsored by the Worldwide Fund. And the problem here is that we have too many regulatory standards. In Chat Report, we just analyzed one standard, and now we wanted to move to a more global scale on different standards. And what we did in the first step was we built an advisory board of people from the finance industry that advised us on what we should look at, also people from regulators, international standard setters, and they indicated about 28 transition plan frameworks. So we went through these 28 transition plan frameworks. We identified the critical questions from these documents, and these are huge documents, and transformed them into indicators that you could ask then to a report. And these indicators then serve as greenwashing flags, and you can put that into some RAG system where you then use again a large language model that analyzes this special flags. But there's a lot of expert knowledge going into this kind of systems. We then identified 26 institutions ranging from national, regulators, monetary authorities in Asia, UK, Europe, unfortunately not the US. Also some big asset managers. We said that we do not give out their names, but these are the most influential asset managers. And we asked them about the usefulness of the tool, where the tool is still failing. And we used that feedback again to eventually improve the whole tools. The outcome is not that surprising. There's a lot of selective communication in the sense that indicators that have a lot to do with talking are well satisfied. Indicators that have a lot to do with walking, so fulfilling their commitments, they are usually red flagged. About selective communication, there's a new paper that comes out because thanks to the regulators, we are always busy. So there was the TCFD back in 2017. Now is the time for the TNFD, because we do not just have to talk about climate, but also about nature. So the task force for nature-related financial risk is also a big thing, was announced at the COP28. And we designed a tool that we call Ask Nature. And in Ask Nature, we were analyzing the top 100 companies identified by Nature Action 100. And some first analysis that we did is, okay, what are these companies that are the most impactful for nature in the whole world? What kind of geolocations do they discuss in their reports? Do they discuss about the real important geolocations or not? And we found that actually what you see here is the more red you see, the darker red, the more they talk about nature in these countries. And the green area is the area which is the most sensitive in terms of biodiversity risk. And what you see is that the most important 100 companies, they rarely talk about Africa, which is kind of strange, right? Because these are the locations that are most impacted by nature. There's another big gap in South America, and in other regions, they only talk very little about it. But this is something you can only analyze with generative AI or with AI, if you want, at scale, right? What we also found is that this is related to some of the postal talks. We wanted to analyze, how do they talk about nature? Do they talk about nature on how the company impacts nature? Or do they talk about how nature impacts the company? Double materiality is very important. And it turns out that they mostly talk about how they impact nature, very little about nature impacts them. And when they talk about how they impact nature, the sentiment about how they talk about their impact on nature is 95% of all cases positive. So yes, we're going to save the world. Isn't that great? I don't know. It's corporate sustainability report. And this questions very much the usefulness of this regulatory standard, this voluntary regulatory standard. Are they really useful? They generate costs for the companies. And at the same time, companies, what they report is basically just boilerplate language and not very useful. So we ask again, maybe this graph here, we ask again the question, are companies making commitments in corporate sustainability report? Remember, when we talk about the Cheap Talk Index, we analyzed annual reports, not corporate sustainability report. Here we analyze corporate sustainability reports. And it seems that they're making lots of commitments. That's great. And are these commitments specific? Yes, they are quite specific. That's great. And then we analyze whether they are potentially legally enforceable. So at 7, legal enforceability would actually become slightly material. So nothing is here. All statements are legally not enforceable. So you cannot take really legal actions on their commitments in this corporate sustainability reports. So the last thing, is it already the last thing? I could probably talk for hours, but the last thing I wanted to share with you is something which is very close to my heart, which is fact checking. And we might start some collaboration with some journalist organizations with this. And the problem is the following. So in this world, one of the biggest risks also identified by the World Economic, the WEF, the WEF, is misinformation. And what you see here is this gentleman who was also the president of the COP28, Sultan Al-Jaber, and he stated a couple of months before the Congress, before COP28, that there is no science out there, no scenario out there that says that the phase out of fossil fuel is what's going to achieve 1.5 degrees. And this is quite tough, right? So how do you do fact checking on that? And how can you ensure that actually people would understand a little bit the problem behind this kind of statements? Of course, scientists stood up and said, hey, this is not true, but wouldn't it be great to have kind of a real-time fact-checking machine? And we created one, and we took a lot of heavy machinery to do so. And the tool is actually called Climinator. And Climinator, it took quite a long time. I used ChatGPT to come up with this acronym. And the acronym stands for Climate-Informed Analysis and Transparent Objective Reasoning. And this tool is actually really great to analyze claims and provide a reasoning. And I'm going to explain you on this next slide how this actually works. So what we did, or what the inspiration for that was, that when we ask a language model these days, we just get an answer from one language model. But do you remember the old Greeks, how they came up with knowledge and the Socratian discourse debating culture that they had? So why not get inspired by this debating culture and use different LLMs, large language models, to debate about the veracity of a climate-related claim? And how did we do that? Well, we defined so-called advocates. And advocates are language models that are grounded on the knowledge, for instance, of the IPCC. Another advocate is grounded on the knowledge of the World Meteorological Organization. Another language model advocate is grounded on the publications of the top 1,000 climate scientists. And then some more general advocate grounded on another huge corpus of climate science articles. And then what you do is you present the claim to these advocates, and they come up with a verdict, whether it's true, half true, or misleading, based on their knowledge. So they provide a whole chain of reasoning of why they come to this conclusion. Then you collect all the verdicts and argumentation from all the advocates, and you give it to a mediator, a neutral mediator, which is again a large language model. And the large language model looks at the argumentation, and if there is agreement, the mediator comes to the final verdict. If there is disagreement, all the text material that was delivered to the mediator goes back to each of the advocates, and the mediator asks follow-up questions to the advocate so that the mediator can make a final verdict. And this opens a new debating round. And in the end, you converge to a final verdict. And why is this important? Because fact-checking usually happens like this. You have, in climate science, you have two web pages. One is Skeptical Science, and one is climatefeedback.org. In climatefeedback.org, you have a claim in a newspaper somewhere or on Fox News or whatever, mostly Fox News. And then you have a couple of climate scientists who write a short paper about why this is misleading or not correct, or and so on and so forth. And this is a lot of time and resources that goes into it. If you have a tool that does the same job and allows you to trace back the whole debating, that would be really great, right? And by the way, this is not just restricted to climate. This could also be done with finance. So I guess I soon have something also in finance, because we collected a couple of 10,000 articles in finance, and we want to use that also to generate hypotheses, new hypotheses in finance. But given that climate is more important than Wall Street traders for me these days, I focus now first on climate. Here are some examples. So Amazon near tipping point of switching from rainforest to savanna. You see already a little bit of a problem. So climate feedback verdict is imprecise. Climinator says mostly accurate. how do you differentiate between imprecise and inaccurate? And the problem is that in climatefeedback.org, there are 13 different categories of veracity, and this puts a lot of pressure on the language model. Then on skeptical science, you have claims that are syntactically and semantically less complex, which, for instance, like climate change before, or it's the sun and stuff like that, which also poses some problems. What we then did is we aggregated these different shades of veracity in different levels. So for instance, we decided to have just 7 categories, then just 5, in the end, just black and white, false or true. What you see with this kind of data, and so we scraped this skeptical science and climate feedback, you actually were able to generate in terms of a binary classification accuracy for our Climinator, the main Climinator model of 98% accuracy, which is really great. I mean, I love it. And results on skeptical science are also quite good. What we finally did is we added a adversarial advocate. So in the US, you have the Heartland Institute, I think it's the name of that organization, and they sponsor the so-called NIPCC report, the non-governmental IPCC reports. I don't remember how they actually label these, but these are really tricky reports. I think they're even written in LaTeX, and they have graphics and tables, but they're all false. But given that they're written in LaTeX and they have tables, it generates some kind of aura of science, right? And these are really tricky. So we defined an advocate and for the NIPCC, and we looked how the debating goes. So we neutralized the mediator, and it turns out that there's actually a little bit more debating involved. So the accuracy after the first round is still quite low, but it increases when you increase the debating. What we also did is we analyzed 2 setups to make it fair. We just included the IPCC as an advocate versus the NIPCC, but still the model converges nicely to the truth. Yes. So maybe last comment on the NIPCC. What I found really interesting is that you have a couple of thousand pages for the NIPCC, so the climate deniers. And then what I did is I extracted claims from the executive summary from the NIPCC, and I was asking the NIPCC quasi-science articles whether they can confirm what is written in the executive summaries. And it turns out that most of the claims in the executive summaries were not able to be verified by the NIPCC. So there's a discrepancy. They cannot even write the executive summary in a consistent way. So that was also kind of revealing. I think time is really running up. There are a lot of problems still there in the use of large language models. So you have to be super careful when you use them, except for some fun applications these days. Some research with Google DeepMind. So this is published and it's going to be presented at the ICML, which is quite a decent AI conference. Is we created a evaluation framework for the output of large language models, because this is really lacking. So how can I evaluate the answer of a large language model? How should I evaluate that? And we collaborated with communications scientists that helped us to define the dimensions, the presentational dimensions and the epistemological dimensions of how these tools should be designed. And it turns out that today's large language models, they really lack the depth that is needed to make really good answers in the sense of our evaluation framework. Maybe the last slide I'm going to show. So I did a lot of different work in the direction of truthfulness of large language models. There are a couple of other papers that really summarize it very well. So if you use, for instance, tools like Bing Chat, Perplexity, there are other great tools. You often have the problem that only half of the statements are usually fully supported by the citations that you get. And only a little bit more than 70% of the citations are accurate. We find similar results in our own research and in our own papers. And I think the most important conclusion for now is that we believe that existing systems, citations, recall, and precision are unacceptably low, given that they are quickly becoming a popular tool for answering user queries and already have millions of users. So that's really a big problem. And if I think about how the tools might also be used by politicians and policymakers, so I have a lot of interaction with the UN, I think it's could be quite problematic, and we really need to speed up the research in the direction of the truthfulness of the systems, so we make sure that actually the output that these models generate do not lead to false decisions that have a big impact then in our world. So that's the end, or the end of the beginning. So there's a lot of research that needs to be done in this direction. And thank you very much for your attention.
Thank you so much, Markus. Great talk.